Like in any other exam, there are a few things you should remember, and the following trig formulae and facts are important to memorize. There is a lot to remember. This lecture handles the trigonometry, and the next will handle all the rest. For some of the facts, we will learn tricks to remember them. For others, we just need to memorize and use them. Almost all the trig can be learned on the unit circle. Consider a point on the unit circle. It is characterized by an angle theta, and we can draw the right triangle with hypotenuse of length 1. The x-coordinate is cosine theta. The y-coordinate is sine theta. Now, take a piece of paper and draw this circle. Imagine the point moves along the perimeter of the circle and concentrate on how the x-coordinate changes, starting at 1, decreasing to -1, and increasing back to 1. Now do the same with the y-coordinate, starting from 0, increasing to 1, decreasing to -1, and back to 0. This is how you should think about sine and cosine, at least in terms of positive, negative. For some people, the following image is also helpful: the signs of sine, cosine, and tangent. Now, we will get to a list of formulae you need to know. I recommend that you keep a small notebook with all of these formulae and equivalences. Keep adding to it as we go and use it from time to time to solve problems. After some time, you will remember all there is in this notebook. So, we have these equivalences for sum of angles. You need to remember those, the signs at least. You can derive quickly by treating a minus b like a plus the angle of minus b. Then use the evenness of cosine and the oddness of sine. For tangent, you can derive the signs by the definition of sine over cosine. It is a worthwhile exercise to derive the tangent equivalence using the sine and cosine equivalences. A special case is where a and b are equal. Then we have the following. Cosine 2a is important since it gives us the ability to reduce the powers from sine and cosine. That is extremely useful when solving integrals. Plug in a equals b over 2, and you will get the equivalence for half angles. Many properties of the trig functions can be derived by observing the symmetry of their graphs. Suppose you have sine of this angle. Immediately, you can observe the 2 pi period. Also, you can see that advancing in only 1 pi takes us to a value reflected over the x-axis. Also, x equals pi over 2 is a symmetry line for the graph. Similarly, for cosine. In addition, we can see that the two graphs are just pi over 2 translation of each other, so we have these two equivalences. We already said that the cosine is even and sine is odd. Do the same exercise for tangent and familiarize yourself with its graph. Finally, we can use the formulae of a right triangle to find the values of cosine and sine given tangent. That is faster than the usual calculation and arises from time to time, especially in solving integrals with trigonometric variable substitution. We use the given tangent value and force the other leg to be 1. Use the Pythagorean theorem and deduce these two equivalences. Now take the quiz. Give yourself the full 2.5 minutes for this question. Stop the video now. The answer is coming in a few seconds. Ready? The answer is E. Using the symmetries, we can deduce the second inequality. This is just a simple quadratic equation in sine A, and the roots are easy to find. Now, we need to evaluate each option. The first one is easy. In the second one, I use an equivalence which I assumed you knew before taking this course. In the last one, we used the equivalence deduced by the right triangle method. Note that in these calculations, we used the monotonicity of the square root function. More formulae to come in the next lecture.